Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video, I want us to explain Pure Mathematics 3 and Chapter 7, Example 7. And Example 7 talks of find the integral of sine 3x cosine 3x with respect to x, and that is just part A of example 7. And the very first thing to capture here is that we do not have a direct integral of sine 3x cosine 3x. We have not come across it here yet, and therefore we must be prepared to write it as a standard integral, and we must be able to recall some trigonometric identities. And with these, the fact that we have 3x here and 3x there, it tells me that we must be talking from a relationship that looks like 2 sine A cos A is always equals to sine 2A. Only that instead of A, we have 3x. And instead of 2, we have a 1 there. It goes without saying, as far as this one is concerned, now 2 sine 3x cosine 3x is exactly equals to sine 2a, which is 6x. And because we need to have sine 3x cosine 3x must be equals to a half sine 6x, and that is just like it. And what we need to do is just now to integrate a half sine 6x with respect to x. This now is in standard integral because we can integrate sine 6x. But again, according to the reverse chain rule, we must have had a function whose differential is sine 6x, and that function must have been cosine 6x. And let us see, if y is cosine 6x, what is dy dx is of course minus, the dy dx is of course minus sine 6x times 6 multiplied by 6, or rather minus 6 sine 6x. So if you look at this, we have had 6 times more than what we expected. So our y must have been a sixth of what we suspected would be our function. And therefore, we are saying that the integral of this one is a half, it's a constant, multiplied by a sixth cosine 6x, of course, plus a constant. And our final submission is going to be 1 over 12 cosine 6x plus a constant. Of course, we remember that we must have a negative there, so all this we are dealing with it as a negative. So at the end of the day, because we know when we have y is equals to cosine 6x, dy dx becomes negative, and that's how the negative sign comes about. And yes, that's it. And of course, now that is the final submission as far as that part is concerned. And I want us to go to Part B of the same question. Part B of the same question. Integral of the sec of x plus the tangent of x and the whole bracket squared with respect to x. And what we need to do here, because the whole bracket is squared, we need to clean it up. And of course, we clean it up by multiplying whatever is in the bracket by itself and opening the bracket, opening the bracket. Let's see what we shall obtain. We have the integral of the sec squared x plus plus 2 sec x tan x. If you use the natural law of opening the brackets, you realize 2 sec x tan x plus the tangent squared of x, of course with respect to x. And at that point, we need to verify whether what we are having are standard integrals. And we can do that by just flipping on page 147, and let's line them up here. We have sec squared x. Is it a standard integral? Sec squared x, yes, it is number 6. The integral of sec squared x is tan x. We also have sec x tan x. Is it a standard integral? Sec, yes, number 9. Sec x tan x with respect to x, its integral is sec x. Of course, the final term is tan squared x, and tan squared x is not represented here. And we can remember we had example 5 of this. In example 5, we were to integrate the tan squared of x, so we have no problem. We can remember how we outlined it. So this one is a standard integral, this one is a standard integral. It is this one we have to rewrite to be a standard integral. Now, how did we go about it? We said the tan squared of x is equals to the sec squared of x minus 1. And that is exactly how we integrated this. So our final format is to integrate to integrate this. We now have to integrate what we have, the sec of x, sec squared of x plus 2 sec x tan x plus sec squared of x minus 1 with respect to x. And now we just have to integrate polynomially, one term after the other, which is, let's have the integral of sec squared x. The integral of sec squared x is tan x. The integral of sec squared x is tan x. The integral of sec x tan x is simply sec x. So plus 2 sec x, and we can verify the integral of sec x tan x is sec x, and 2 is a constant, and therefore we have plus 2 sec x plus tan x minus x, because the integral of sec squared x, is tan x, and the integral of -1 is minus x. Now what we need to do is simply now to collect the like terms. and you can see tan x, another tan x. Our final submission becomes 2 tan x plus 2 sec x, of course, minus x, and because it was not having limits, so we add a constant, and that is exactly what we need to acquire at the end of the day. So again, please note, it's a long question. It looks short but long, but you need to put all steps together. But of most importance is to identify the integratable trigonometric ratios, and those which are not, rewrite them in standard integrals. All right.